Cleaning messy data. This is going to be our sixth pandas use case. In this video, we are going to take a look at using pandas to identify messy data and industry standard data cleaning techniques to tend to it. So let's head over to our notebook. We quickly get the imports out of the way. Now, one of the main problems with messy data is identifying it. How do you even know whether it's messy or not? Let's use the NYC311 service requests dataset again, since it's a big and messy dataset, enough for us to go forward with. So we read the data using read_CSV, and we take a shot at identifying whether the data is messy or not. We're going to take a look at a few columns here. I know already that there are some problems with the zip code, so let's look at that first. To get a sense of whether a column has problems or not, we usually use a .unique function in pandas to look at all its values. If it's a numeric column, I'll instead plot a histogram to get a sense of the distribution. When we look at the values or the unique values in incident zip column, it quickly becomes clear that this is a mess. So what are some of the problems that I found out? Some have been parsed as strings and some as floats. There are NaNs, which means there are missing values. Some of the zip codes have a hyphen in between them, and some of the zip codes are as bland numbers as 83, which really don't represent a proper zip code. There are some NA values that pandas didn't recognize, like NA and no clue. So what we can do is normalize NA and no clue into regular NaN values, look at what's up with the 83 and decide what to do, and make everything strings. So we use a .unique function to identify all the abnormalities we just discussed. Once you get the notebook and start working on your own, you can actually look through the output very carefully to identify some of these anomalies yourselves. Fixing the NaN values and string float confusion. We can pass NA_values option to read_CSV to clean this up a little bit. We can also specify the type of incident zip. We can also specify that the type of incident zip is a string and not a float. So we make a list of the NA values. So these will be values when seen in the data that will be converted into NA. We grab 311 service request CSV from the data folder and then pass these list of NA values that we just came up with to the NA_values option in read_CSV function of pandas. And then finally, we specify the data type of the incident zip column as a string. So we now have a much better way to read the pandas data frame. And now if we do a unique, we'll see that some of those problems have been fixed. I cannot be able to see the NA or the no clue values anymore. And now let's move on to tending the dashes. The incident zip column contains hyphens in the pin code. We are going to use the string manipulation techniques that we learned in the previous videos to identify the values in the incident zip column containing hyphens. And then if we take a look at it, we'll see that there are hyphenated values in the incident zip column that we have filtered out. I thought these were missing data and originally deleted them using the below code. But then it occurred to me that 9-digit zip codes are normal. So let's look at all the zip codes with more than 5 digits and make sure they're okay and then truncate them. We are again going to use the string manipulation techniques to subset out the incident zip column values that are greater in length than 5 and then pluck out the unique values out of those filtered column. So these are the unique values that we see across our data set, and we'll set a strategy to truncate them. So all we have to do is select the first 5 characters out of these values. So we're going to use the dot slice method to specify what should be our starting and end index of a particular value that we want to subset. Done. Earlier I thought 00083 was a broken zip code, but it turns out that Central Park's zip code is 00083. Shows what I know and what I don't know, doesn't it? But I'm still concerned about zip codes that have all zeros though. Let's take a look at those. So we actually have values in our data where the zip code is fully 0. This doesn't look right. So we'll set these values to NaN. Done. So let's see where we are now. We'll go back to using our unique method and see what are all the things that we have done so far. So we have tended to values like NA, no clue. We have looked at zip codes having a length of greater than 5. We have looked at zip codes that have all zeros, and we also have tended to the 00083 zip code for Central Park. And now look at how normalized, much cleaner the data looks right now. But there's still something a bit weird though. I looked up 77056 on Google Maps, and that is in Texas. So we'll take a closer look. From the requests data frame, we are again plucking out the incident zip column. And now, if we assume that zips starting with 0 and 1 are okay, then we subset out that data and we are left with these zip codes. So if we especially take a look at the cities, the corresponding cities for these problematic zip codes, we see that there are requests coming from Los Angeles and Houston. So the 311 service requests have data that are coming from LA and Houston. Good to know. Filtering by zip code is probably a bad way to handle this. We should really be looking at the corresponding city instead. So we do our typical value counts on the city column this time by changing them all to uppercase. And the reason why we do it is, imagine in a row we have a city, New York, that is spelt like this, and in another row, New York is spelt like this. In order to normalize those values, what we do is we convert all of them into the uppercase and then do a value counts in order to resolve the problem. So we now get the counts grouped by cities, and it looks like these are legitimate complaints, so we'll just leave them alone. Finally, we put it all together. Here's what we ended up doing to clean our zip codes altogether. We set the NA values that we did not want to look at, or we wanted to replace them with NaN values. Used a list of them to replace, set the D type of incident zip to string. And now all of the stuff that we did one by one, we're just coming up with a consolidated function that does it for us. So we're going to truncate everything to length 5. We are going to set the 0 zip codes to NaN, and then finally we're going to return that. So now all we have to do is pass our custom function fix_zip_codes And inside, we need to pass our pandas series. And once we get the output, we can just assign it back to the incident zip column to get our normalized values. So these are some of the techniques for cleaning up messy data. It largely depends upon our common sense, our curiosity to dig down deep inside the data, and of course, using the convenience methods in pandas to cater to them.